Think forward. Think Research Channel.
With that, I give you Dr. Greenberg. Rick, you haven't done anything yet this hour, but I do want to present you with a gift to tell you that we really do appreciate you around here.
Thank you very much. It's a very warm introduction. I don't know how much of that I really deserve, but it's a distinguishing honor for me to give this lecture. This is a picture of my vaccine research team who's made a lot of what I've done possible. And it's a very difficult type of endeavor to do, and they work very, very hard to achieve what they've done. So let me begin by introducing someone who I like to think of as the father of vaccination, but maybe you all may refer that to Louis Pasteur, but he honored Edward Jenner, who's up on your, as you look at the screen on your left, who was the discoverer of vaccination. And, you know, actually, he really wasn't the discoverer of vaccination, at least the way I see it. What he did was clinical research, and he did a little bit more than that. He tried to publish his clinical research in 1798, I believe, and it was rejected. So I think we all may relate to that. And, of course, after that, there was a lot of angst, and he was advised to publish this, keep trying. So he did. He published it himself. And that treatise stands the test of time and has distinguished him from others of his time, especially as it relates to vaccination and smallpox. Let me just divert for just a minute to let you know that there was a farmer in England about the time Edward Jenner set up practice who actually thought that cowpox infection, which is a pox or pustular lesion that was seen on cows, especially udders and milkmaids would pick this up, would prevent them from coming down with smallpox. Smallpox would go through villages in England every 5 to 10 years, and those people who had not had smallpox, about 30% would die. Many, many others would be maimed for life or scarred or something like that. But those who had had cowpox didn't get the disease. So Benjamin Jesty recognized this in the early 1770s. The milkmaids knew about this. But what Edward Jenner first did is he took a milkmaid's lesion, a fresh pox lesion from a lady named Sarah Nelms, and injected it on the skin, just under the skin surface, and on top of the skin, to a young 9-year-old lad named James Phipps. And then about 6 weeks later, he gave this individual smallpox, and he didn't get the disease. He didn't react at all. And then he went on to do his clinical research, publish, and the rest is history. And on the bottom is a summer house where he would vaccinate individuals in Berkeley, England. If you go to England and you're in this area, you can there's actually now a museum for Edward Jenner. I'm going to talk about 3 vaccines today in relative detail. The first one is the vaccine to prevent shingles, and I'll explain the disease and explain the vaccine. The second one will be the current status of vaccination against the disease. It's already eradicated, but of great concern for bioterrorism event, smallpox. And then I'll end with a short discussion on the human papillomavirus, which is a very topical vaccine these days. So this is my modern-day Edward Jenner. His name is Mike Oxman. He works in infectious disease at the University of California in San Diego. He visited us. We were part of his clinical trial. There's Mike, my daughter. We're out at Gainesway Farm. And what Mike did is he was literally possessed to some degree, a big degree, to do something to prevent shingles. And he recognized what was in the literature. He knew the contemporaries doing the clinical research and put it all together, led a clinical trial that ended up with a very successful vaccine that we can give to people over 60 years of age. It doesn't completely eradicate shingles, but certainly is effective in preventing it and much of the severity that goes along with the damage the virus can cause to nerves. So Mike Oxman says shingles live silently in the body for years. And what he's referring to is a virus called varicella zoster virus. It typically pops up over the age of 60. He credits a paper written in 1965 by a British general practitioner as a major inspiration for his study. It was all there in Edgar Hope Simpson's landmark paper. Now, Edgar Hope Simpson was a general practitioner, not necessarily an academician. And he got his information for his clinical observations from his own notes of his own patients. And what Hope Simpson put together was a hypothesis that individuals develop shingles as they age because their immunity to the virus, the herpes zoster virus, weakens. He concluded that people rarely develop shingles more than once because their first episode boosts their immunity to the virus, effectively immunizing them against another attack. Now here's the varicella zoster virus. It's a double-stranded DNA virus. And just as an aside, if you talking about viruses and vaccination, I'm going to talk about 3 viruses today that are DNA viruses. Their genetic makeup comes from their own DNA. These viruses do not mutate nearly as much as RNA viruses do, like influenza, where you have to get a shot every year. Here, there's some durability to immunity, although mutations can occur. It's not nearly as rapid as we see with HIV or influenza or other RNA viruses. So varicella zoster is a DNA virus belonging to the herpes virus family. In years gone by, it was called human herpes virus 3. Only one serotype is known, and humans are the only reservoir. VZV enters the host through the nasopharyngeal mucosa and almost invariably produces a clinical disease. And you all know that disease is chickenpox. The incubation period is usually 2 to 3 weeks. So here you see a young lad with chickenpox, and you see microscopic pictures, electron microscopic pictures of the virus. Now, varicella, which causes chickenpox first, is so common that most people who were born in this country who've attained the age of 40 or older have almost 100% exposure to the virus, 95% plus. So it's that common and it's that easy to transmit. A doctor who was doing a fellowship at Baylor named Takahashi, his child, and according to the literature, he was 3 years old, came down with a bad case of chickenpox. So while at Baylor, he must have dedicated himself to doing something to prevent this viral disease. And when he returned to Japan, he worked with a group of people to attenuate a strain that they isolated from a young Japanese boy, the family name being Oka. So the Oka strain of varicella zoster virus is the strain, it's an attenuated strain, that we have in the chickenpox vaccine, and we also have it in the zoster vaccine. And he attenuated this so successfully that it was tested in 1974 and reported to stop an outbreak on a children's ward in Nagoya, Japan. It was licensed in several Asian countries in the late 1980s, Japan, Korea, etc. And the amount of plaque-forming units in this particular vaccine is relatively small considering what we have in the shingles vaccine. The American version is about 1,350 plaque-forming units for this vaccine, which we give to young children to prevent them from coming down with chickenpox. Interesting little story is that families in this country whose children either died or were severely ill from chickenpox after this vaccine was licensed in Japan were angered that the United States did not have this vaccine available. The FDA had a lot of pressure on it to get this vaccine approved. It was approved in 1995, but prior to its approval, there were 4 million individuals in this country yearly coming down with chickenpox, 10,000 hospitalized, and 100 deaths. So it's a very valuable vaccine. In a way, it's a shame it took so much extra time to get it approved, but there were concerns about its safety. So when it finally was approved, it was recognized that it was very effective, almost 100% in protecting individuals from chickenpox, and the durability was thought to be maybe 20 years. But the vaccine has been so successful that it has eradicated so much in this country, the chickenpox, that natural boosting and exposure to individuals who'd been vaccinated doesn't really occur as much anymore. Last month in the New England Journal, there was a paper actually documenting the need for boosting individuals 5 to 10 years after they received their original attenuated vaccination. So very interesting, seems to be relatively safe vaccine. So how do we get to shingles? This comes from actually like an op-ed article in the New England Journal from last week. And so I took this picture from it. Chickenpox from the skin during the outbreak finds sensory nerves and sort of stealthily goes back to what we call a dorsal root ganglion, which is connected to the nerves that come out of the spine that serve a sensory function. And there it remains latent, and it can remain latent for decades. Why it is reactivated or how it is reactivated is poorly understood, but when it's reactivated, and if it does cause disease, that disease is shingles. And it comes back out stealthily through the nerve root, winds up back on the skin, but here now localized to where that particular nerve innervates. And we call that area a dermatome. So if, for instance, it were to come out on the left side in the T4 dermatome, which would be coming through the thoracic vertebrae, this actually services, when it goes around to the front, the breast area. And there are individuals who may go to the emergency room with chest pain, confused as being a heart attack, because prior to the onset of the particular rash, there will be nerve damage as the virus travels through that nerve root. And I'll show you a clinical example in the next slide. But the question is, why does this happen? Now, Edgar Hope Simpson said immunity weakens. And indeed, the studies that were done looking at cellular immune responses, that's not the antibodies, but it's the cellular immune responses, actually cells that go after the other cells that have the virus in it, weakens. It weakens to the point that about 50% of our ability to fight off this reactivation is lost by the age of 60. And by the time you reach 80, you stand a 50% chance of developing shingles because you've lost cellular immune responses to the VZV virus. Now, I wish we could bring back Red Auerbach to be our coach. Wouldn't that be wonderful? But Red was a friend of the family, and especially to my dad, who was part of his China gang, if you've read autobiographies about Red. And about shortly after this picture was taken, my father developed shingles down his right leg. And for the last 10 years, he's had to wear special shoes, has periodic sharp pains going up the right leg, and recently he tells me that because he's had to change the way he walks, he now has pain in both legs. He's a well-to-do individual, and there is no cure for this, what we call post-herpetic neuralgia. And he said to me yesterday, be sure to let everybody know that if they turn 60 and are well, they should get this vaccine. So that's him saying it, not me, from the suffering that he's gone through. Now, and that's typical of people who have a bad case of shingles and have nerve damage. So here is the clinical course down here. It says tingling and burning pain. This is when the virus is traveling through the nerve going back up to the skin. When it gets to the skin, a rash appears, and the rash has a red area, vesicular pustular, it looks like this, comes in crops and circles around the front where the nerve goes, and it's in that dermatome area. and I show you the pustules scabbing, and then they can leave some scar tissue. The pain is related to the nerve damage. And we can treat shingles with drugs like acyclovir, which kill the varicella zoster virus. And we like to tell physicians to get the antiviral medicine started within 72 hours of the onset of the rash. But you now know, because I pointed out to you, that the nerve damage actually begins before the disease might even be recognized. So if that nerve damage is really bad and it's irreversible, in some instances if it's really bad, the pain gradually the pain can last weeks to months or even a lifetime after someone resolves their skin portion of this illness, even if they took acyclovir or one of the other derivatives that are on the market. I got an email from an individual who had shingles and he wanted help. He's 71 years old, and I took this out of his email. I still have the pain. He had shingles a year ago. This was his 1-year anniversary. It's restricted to the left side of my chest. An early morning shower is painful, but it diminishes after a few hours of activity. I took pain relievers for months, but stopped as I felt no decrease in the severity or frequency of the pain. The nerve damage is such that they get something we call allodynia, which means pain out of proportion to the touch. So even a nice, comfortable shower can hurt an individual with the nerve damage in the area where the nerve is damaged. So what can we do about it? What did Mike Oxman do that resulted in such a great study? Well, the vaccine is made by Merck. It's called Zostavax. It's a more concentrated version of the chickenpox vaccine. It's got at least 19,400 plaque-forming units. It's an attenuated OCA strain. The only contraindications would be someone who's immunocompromised or has an allergy to what's in the vaccine, primarily gelatin and neomycin. Here's a copy from the New England Journal of the article that actually was used by the FDA for approval for individuals over 60 years of age. In this study, which we were part of, a total of 38,546 individuals were enrolled over the age of 60. They were stratified 60 to 69 years of age or over 70. Half were given vaccine, half were given placebo. At the end of the trial, 315 individuals had shingles who received the real vaccine, and 642 had shingles who received placebo. If you look on your right, and it says zoster vaccine, incidence of zoster, you see a 50% decrease in those who came down with zoster. And of those who had zoster, you see a 2/3 decrease in the incidence of the post-herpetic neuralgia. And if we delve a little deeper into this and look at the burden of illness, meaning duration of pain and severity of pain, there is almost a 2/3 reduction in the burden of illness in those individuals who received the vaccine. And the last slide on shingles vaccine describes what we found in the study. Herpes zoster and post-herpetic neuralgia occur more often with increasing age. Again, I can't stress enough, the crossover line appears to be 60. Now, you can get the neuralgia in a small number of people younger than 60, but as you get over 60, it's much more common. In this controlled trial of 38,000 plus adults over 60, vaccination with a live attenuated varicella zoster vaccine reduced the incidence of post-herpetic neuralgia by 2/3 and the incidence of zoster by about 50%. The side effects that we saw were local. There were no severe adverse reactions, and boosting immunity to varicella can reduce the incidence and severity of zoster. What this is trying to say is that perhaps it's not contraindicated to people who've already had zoster once, although that's not an indication, but it's not a contraindication. And the conclusion, I love this conclusion, the zoster vaccine markedly reduced morbidity from herpes zoster and post-herpetic neuralgia among older adults. Very simple. And then from the op-ed type of review that was in the New England Journal, both authors recommended that the vaccine be universally administered to healthy, immunocompetent persons 60 years of age or older, provided there is no contraindication. I want to move on to smallpox. This is a disease that's eradicated. It was eradicated in the 1970s, and subsequently endorsed by the World Health Association in 1980. This is what might we see if there was a bioterrorism release of smallpox. Millions of people wanting to be vaccinated. The strategies, of course, will depend on the mavens who are going to instruct the government on how to deal with the smallpox, but conceivably there might be millions of Americans who've never been vaccinated before. We call them vaccinia-naive individuals versus those who received vaccination when they were a child in the 60s and 50s. We call them vaccinia experienced. But there'll be millions of people, vaccinia-naive, getting the vaccine for the first time. Now, this is like a short little film, but I couldn't animate it. I was over in India helping in the eradication program, one of many, many worldwide scientists that were involved, thousands. There were hundreds from the Center for Disease Control, and I just happened to be one of them. I took this picture of someone who had smallpox. I actually saw cases of it. We used this bifurcated needle. The top one doesn't have anything between the tines. The bottom one has the vaccine in it. We gave 5 to 15 little punctures. We call this scarification. On the surface of the skin, drew a little blood, and that was our vaccination. This gentleman is a holy man who, I was in India. He came to the village. We were containing this village because of the smallpox cases, and at first he wasn't too happy to be vaccinated. But I want to tell you, this was a posed picture. And I loved it because he had this picture of a bifurcated utensil on his forehead. And here we explained to him what we're doing, and we vaccinated him, and he said, I'm going to dedicate this year for preaching to stop smallpox. Little did I know that here at UK in 2002, the military would develop a new version of the vaccine, what we call a second-generation version, and we were their one and only site to take a look at this new version of an old vaccine. And here is Dr. Holsinger and 2 individuals from the contracting company Dyneport. In our armamentarium right now, we have 2 first-generation vaccines. And what I mean by first-generation vaccines is they're grown in animals and given as scarification with those punctures. We call them dry vax and wet vax. And in fact, dry vax, which is currently approved by the FDA, is actually going to, I'm told, that approval is going to run out. But we'll have these first-generation vaccines in our armamentarium with millions of doses, and it looks like they can be diluted. I don't know if that'll be the strategy. So we have a lot. But those are old vaccines, and they were grown in animals. Now, why can't we have a vaccine today coming from an animal? Well, we have diseases that have gotten into the human population like bovine spongiform encephalopathy. And in fact, the vaccinia is grown in cows. So we needed something that was adapted to cell culture. So that's second generation. These second generation vaccines, and I show you, they look much cleaner than what's scraped off the surface of the skin of a calf. This looks like mucus, and I could put probably somebody's mucus in there and it would look like smallpox vaccine. Very sticky and hard to dilute. The second generations look like water. And they're cell culture adapted, and they are slightly attenuated, hopefully a little safer. But they are replicating. And I want to get into a little theme here about the dangers of smallpox vaccine so that you know why people are thinking the way they're thinking, or so-called dangers. Taking someone who's vaccinia naive, and we give them the punctures, about from day 4 to day 7, a pustule appears. It starts to look like a nice 1 centimeter pustule with inflammation. A week later, we see ulceration, and then anywhere from 2 to 4 weeks or so is scabbing. The scab falls off and reforms until finally there's scarring. At any particular time here, the vaccinia can be contagious, can be spread from skin-to-skin contact. Only skin-to-skin contact. It's not contagious any other way. Now, there have been papers published as case reports of military recruits who are getting vaccinated these days with the first-generation vaccine. going home, a little R&R with their wife. The wife comes down with a vaccinia, an inadvertent or not planned vaccination, and sometimes it's been on the breast. And then they have a young child who picks up an oral vaccinia inoculation from the mother. So, in fact, years gone by when we were using this vaccine, people would have vaccination parties. So someone who just got vaccinated could vaccinate others. As recently as 1930, which is really a far way, but a lot of us think it was just the other day, there were over 43,000 cases of smallpox in America. So it's very contagious. It's confined to humans. There are no animal reservoirs, but very contagious and, of course, very lethal. So it turns out that vaccinia, which is a relative of the smallpox virus, has cross immunity. So we want to give people this vaccination to prevent the smallpox, and this is what's on their skin. So it can be cultured from the site, and healthcare workers can be vaccinated. They just got to keep this covered and not scratch it, and it does itch a lot. Now, here at UK, we were involved in many smallpox trials in the last 4 or 5 years. And here we were involved in a second-generation cell culture vaccine from Japan called LC16M8. It's attenuated. And I just want to briefly say that the immune responses appeared similar, and it appeared the safety equal with the dry vax. But I wanted to point down here, no evidence of pericardiomyopathy in either group. Now, what the heck is pericardiomyopathy doing with smallpox vaccine? You know, you get these skin lesions, but how's the heart get involved? Turns out, if you look at the literature, it was described in the French literature, French foreign legions, legionnaires actually had some heart disease after smallpox vaccination back in the 50s and 40s. And this was actually in the literature. So this is not new. It was just sort of rediscovered when another vaccine, second generation, was studied, and we were part of it. When out of 1,132 volunteers at the time the study was halted, there were 8 cases, or 1 in 145, associations. Now, we're not sure if the vaccine did this, but temporally they occurred within a month after vaccination of a myopericarditis. There were no deaths, but there was relatively clear documentation something was going on. At the same time, the military looked at their records, and they had a 1 in 8,000. Well, this is clearly too much. Other things associated with a smallpox vaccination are it's a robust take. About 10% of people will get a lymphangitis. Don't be scared, it's not bacterial. It goes away without anything more than symptomatic care. But when we first saw it, it was rather striking. Oops. This is satellite lesion. So not only can it be spread to another person, the same person can have several lesions develop near the vaccination site. They heal rather quickly. It's just more possibility of spread. The Band-Aids that we put over the vaccination, a lot of people react to the adhesive. Well, these aren't too bad. When we saw this, we were a little frightened. 2 kinds of rashes after vaccination. This was a pustular vesicular rash that went away rather quickly. This, for all intents and purposes, looked like measles. Symptomatic care went away. The individual had this, no problems, other than she looked funny. And about 2 weeks of this, and it went away. The important thing is, and we published, is to let doctors know these nonspecific rashes can occur after a vaccination. Now we get to the bad ones. These are old pictures. This is generalized vaccinia in a young kid. You can see his vaccination site, and he's got virus all over. This potentially is lethal. So is this. Progressive vaccinia. This lady not only had it in her arm, she inoculated her face and couldn't defend herself against the vaccination virus, the vaccinia. And this is a lady who had eczema. The lesions, her eczema lesions got colonized with the vaccinia. It got in her blood. She had generalized vaccinia after that, and this is lethal. In fact, there's a case report of a transmission from a recruit to a wife to a baby with eczema who is now recovering. We have vaccinia immune globulin that we can give to individuals who have this, and most of the time it's effective. But it's obviously a terrible complication. If we look at the death rate of when the vaccine was given in the late 60s, this was done by a group headed by Michael Lane, who's an expert in all of this. He points out in his group, in 2 surveys, about a 1 to 2 per million death in vaccinia-naive individuals, and about 1 in people who were revaccinated. So the vaccination is not without risk. And in one article that I read, the risk, if you look at people or people they're associated with who might pick it up from them, could be as high as 50% risk for something. And I list here, immunosuppression, HIV, eczema. So the National Institute of Health resurrected a very interesting vaccine, a 3rd-generation vaccine called MVA. Now, MVA came from a vaccinia strain that was kept alive in animals, and it was passed between donkeys and another animal. I believe that animal was a cow, but donkeys were part of this. And a German scientist took this vaccinia strain and attenuated it after over 500 passages. And they were very successful in attenuating this. They really attenuated this one, much more than the 2nd generation. And this vaccine is quite interesting, even today, for not only possibly being used as a vaccine, this vaccinia strain, but maybe as a platform for many other vaccines, because it's easy to give, seems to be relatively safe, and a company has not only pointed out the deletion sites on top of the DNA I show here, but the integration sites on the bottom where anybody can pluck in a antigen and see if they can't have a vaccine. So this is derived by passing through a donkey and other animals, but now it's maintained in cell culture using chick embryo fibroblasts. The 2 properties that I see that make this incredibly interesting is, number 1, they deleted the ability of this vaccinia strain to replicate in human cells. So it's got to be maintained in animal cells. And if you look at what the vaccinia virus has as its armamentarium, it has some stealth proteins in it that interfere with the body's immune response, at least initially. And these immunomodulatory proteins are gone. Some of them are gone. So you have an antigenic vaccine that's non-replicating, so you can see how it might be safe, and an immunogenic. Now it's not given on the surface of the skin. It's given as either an intradermal, subcutaneous, or intramuscular injection. And here in our studies where we've used it here at UK, we've given it as a subcutaneous injection. Now, this study was published earlier this year, comes out of the NIH, and what they show here, the Germans actually reported 30 years earlier, and I thought it was interesting and colorful, so I can go through it with you. But this is the normal course of a vaccination duration time in someone who's never been vaccinated before. Here it's a little attenuated. Here it's a lot attenuated. So in people who've never been vaccinated before, you see 80% red. If they receive 1, 2, or 3 doses of the MVA, you see yellow. If they receive 1 vaccination with Dryvax, the 1st generation, and followed 12 weeks later with another one, you see yellow and blue. So you see an attenuation, but not as good as the 1st generation vaccine. In individuals who've been vaccinated before, here they have a lot of yellow with their Dryvax or 1st generation vaccination, and you see less yellow and more blue if they receive 1 or 2 doses of the MVA. Now, unfortunately, the dose that was used at NIH was 2 logs lower than what it should have been. It was not the fault of the clinical researchers. It happened to come from some quirk in manufacturing. They really didn't see much of an antibody response, but they saw a response with cellular immunity. taking this from a review paper, looking for adverse events with MVA over the years, either from the German literature or from the American literature, there have been no reported instances of mild pericarditis, just local reactions at the vaccine site. Now, we've done 2 studies here with MVA that are part of my talk today, and we've done others as well. And the first one looks at the humoral immune response at 2 different assays. One we call a neutralization of the virus assay, which is the 3rd dot, and the 4th dot is an ELISA, antibody binding assay. And after 2 doses of the 10 to the 8th, which is 2 logs higher than what the NIH used, we do see 82% seroconversion in one assay and almost 100% in the other. The second study I briefly want to talk about is one we used where we had volunteers where we used MVA in volunteers who had HIV. Their CD4 count wasn't too low, 350. They didn't have AIDS. But 350 is certainly lower than normal and shows an effect of the HIV virus. So we had 4 groups, vaccine-naive groups and vaccine-experienced groups, those with and without HIV. Everybody got 1 vaccination, and then 4 weeks later, those who were vaccine-naive got a second MVA vaccination. There was no first or second generation vaccine here. They only got the MVA. And the results are quite interesting. If we look at, it says day 38 to 49, that's about that's after the second vaccination in the vaccine-naive group, you can see comparable seroconversion rates between those with HIV and those without HIV. And if we look at day 28 and 35 with the blue and the red, this shows actually the seroconversion rate was slightly higher in those vaccine-experienced people who got MVA. So the conclusion from this study in HIV patients, there were no cases of unexpected or serious vaccine-related events within 28 days after the last vaccination, and seropositivity and seroconversion rates following vaccination in HIV subjects were comparable to those who were uninfected. Now, currently, our focus with MVA is in individuals with atopic dermatitis and HIV as the key vulnerable group, and particularly those who are vaccine naive, who've never had a smallpox vaccination. We're thinking of using 10 to the 8th plaque-forming units per dose and giving them 2 doses. The issues here, and the last thing I want to say about smallpox vaccination, is because the disease was eradicated back in the 70s, we really do not have an adequate model that tells us that these new vaccines, either 2nd or 3rd generation, will be effective. We are hoping that we can come up with a clear formula and directive so that we can adapt these vaccines in case there were a post-event setting. And that's the other focus. We are thinking to not use this for first responders pre-event, but as a post-event vaccine. I suspect that the story with this vaccine, MVA, will be completed in 3 to 4 years. And perhaps, I'm hoping we'll have this vaccine out. And I'm thinking of the elderly as well because of the paramyocardopathy. I think that's a vulnerable group, too, that should be studied to verify the safety of MVA and the boosting response to those people. And, of course, they'll be vaccine experienced. Now, the third vaccine I want to talk about has some political overtones, and I don't think you've heard the whole story. What's been covered in the news has been more or less who should get it. But this is a wonderful thing that's happened. Now, the human papillomavirus cannot be grown in culture. So because it requires differentiated cells, and they just don't grow. You have to use undifferentiated cells for cell culture to have an effective, easy cell culturing. I'm sure someone will adapt something some way, and maybe there will be a better way to do this. But what they did is they expressed the antigens, perhaps antigens that could be used in a vaccine in another system. And they used the DNA sequence, because this is a DNA virus, to generate the proteins. Now, the papillomavirus is a non-enveloped icosahedral capsid enclosing double-stranded DNA. And the capsid is bold because that's very important for you to know. Now, very few, but importantly, some of these human papillomaviruses seem to cause cancer or are related very directly to cancer. And they do this by two proteins that some of these make that are rather aggressive proteins. Now, papillomaviruses may make versions of these proteins, but it's certain types that have this aggressive protein, these proteins, E6 and E7. I thought this was interesting because they affect apoptosis when it should occur by downregulating or suppressing a tumor suppressor protein called P53, and they affect the retinoblastoma gene product, which is important in cell cycling. So they actually have carcinogenic-like proteins that they can express, and that's important to know. It's a very common virus. Maybe as much as 50% of sexually active males and females, we lump them all together, we could find HPV virus in them, but very few have the ones that express these aggressive proteins, and that's also important to know. Very common, but also very rarely do we find the ones that relate to the cancer, but they're there. So if you look at the data and read it very, very closely, HPV DNA can be found in 10% to 15% of adult human U.S. population. It peaks at close to 50% in the most sexually active age groups, which appears to be in the 20s. Mostly, and when it does show up, it's mostly in benign skin lesions. Most of the time, our immune system copes with the HPV, and without treatment, it goes away as a wart. About 1% of the population has genital warts at any one time. It's called condylomata acuminata. There are types 6 and 11, which are low-risk HPV types. They're not necessarily associated with cancer, but are found in more than 90% of the warts, anogenital warts. Now, I show this picture of a lady with the virus and write anogenital cancer. Two particular types, 16 and 18, are found in about 70% of anogenital cancers. In 2006, there were 9,700 cases of cervical cancer, 3,700 deaths, and 5 times as many cervical cancer in situ. And I want to point out, as common as this is, or as we see it in females, we see it in the male gender as well. I've had 2 cases this year of males in my clinic die from rectal cancer related to an HPV infection, and it is sexually transmitted. Now, what's the beautiful thing about this? In doing the science of expressing these proteins, that using a yeast system, it was found that one of these 8 proteins, called the L1 major capsid protein, self-assembled, and for all intents and purposes, it looked like a virus. So they call it virus-like particle. And with the assistance of an adjuvant, which boosts the ability of something to become antigenic and give an effective immune response, this VLP, this virus-like particle, expressed in a yeast system, was indeed antigenic. This science was given in some way to Merck and to GlaxoSmithKline, and I'm assuming at the same time these companies probably had scientists of their own working with the NIH to get this information out. But it was an article, first of a series of articles by different authors from different groups, appeared in 1991, showing that this self-assembled L1 major capsid protein is antigenic. Now, I point out to you in this long paragraph, second paragraph here, what's in the Merck vaccine. And the Merck vaccine has antigenic material in it, the VLPs, for human papillomavirus types 6 and 11, the ones that are common in anogenital warts, not cancer, and types 16 and 18, which are common in American cancers of the anogenital area. Now, the rest of the world have other types, like 31 and 45, so I suspect there's going to be more of these vaccines utilizing this technology. Merck has a proprietary adjuvant, an amorphous aluminum hydroxyphosphate sulfate. Glaxo has their own proprietary antigen. Merck's vaccine has been approved by the FDA, and the Center for Disease Control Advisory Committee for Immunization Practices says it should be routine for 11 to 12-year-old females. It's only approved in females 9 to 26 years of age because that's how the studies were done. It's a quadrivalent vaccine given in 3 doses. It's not live. So the contraindications to this vaccine would be allergy to what's in the vaccine, and there's no thimerosal, there's no antibiotics. So it looks like just about everybody might have some chance of getting the vaccine. Very rare would it be contraindicated. The Glaxo vaccine is not yet approved, and it only has the anogenital cancer types 16 and 18. I want to show you some data real quickly. It may be hard to see, but this looks at geometric mean titers. And I want to talk about the durability of the immune response after 5 years. And you can see after 5 years down here with these 4 antigens, 6, 11, 16, and 18, there still is a significant geometric mean titer, meaning the durability, at least now, and you've got to take into effect there could be boosting going on in this group if these individuals who got the vaccine were then subject to 16 and 18 or 6 and 11. We don't know that. It seems durable for at least 5 years. The Glaxo product also looks durable for at least 5 years. This is a different assay they used. It's got a different adjuvant in it, but both vaccines look like the durability is at least 5 years. This slide is to remind me to tell you that it seems to boost the immunity or have an immune response in girls, boys, and women. And I bring this up because we have to think about the proper strategy with this vaccine. Why just give it to women when both men and women carry the virus and can be exposed to the virus? So on one hand, I think in order to eradicate or reduce the incidence of cervical cancer, anogenital cancers, maybe we should be giving it to both young boys before they're sexually active, as well as young girls before they're sexually active. On the other hand, what about natural boost for the women? So this all will have to be thought out, but my guess is this will eventually be a vaccine for both genders. And if we look at the cases of cancer that occurred or abnormal pap smears that were precancerous, and this is to remind me to show you, there were no cases that occurred in years 3 to 5 in the Merck trial. And if you look over here on the far left, the efficacy, both infection, disease, pap smear, is about 100%. So I think this is a wonderful new vaccine everybody needs to think about, especially if they have a young girl in their family. I see no reason not to think about it. The concern might be, well, it hasn't been around long enough to be clear that it's safe. But I think you can see the way it's made, that probably will, it suggests to me anyway, that it'd be highly unlikely that we're going to see something unusual. Now, I've got 2 slides, this and the last one. Anthrax, plague, this is botulism, if I saw this on the internet, scarfed this from the internet. Toxins A and B, West Nile, and C. diff toxins are vaccines that we've studied here at UK recently. My stepfather died from C. diff disease. I really would like to see a vaccine to prevent. This is a necrotic colon that we took a picture of at autopsy from a lady who died here from C. diff disease. So I'm sure all these have vaccines against all these diseases would be a great benefit and interest to all of us. Anthrax has already been a bioterrorism, and these other, West Nile, we're always concerned about during the spring to fall. And of course, because we work in the hospital, it would be great not to have to deal with C. diff disease, especially now when it appears to be a more virulent disease than it used to be in the past, and it's more common. And lastly, I want to make a bunch of thanks. First, to the group that has been with me for over a decade, come and gone, some of these people, but these are the individuals who worked with my vaccine trials and made it all possible. And this group of people who decided not to open up their racetrack till tomorrow.